Hey everybody, it's Jenny from Norman S. Wright. Let's continue on with topics related to fans. So this week I want to answer the question, what is system effect? Let's get started. System effect is the negative impact on fan performance that results when a fan is connected to a duct system. So fan performance data is taken in an ideal lab condition. This allows you to look at fan data and know that at a certain pressure and RPM, the airflow will be a certain CFM. It makes it repeatable and comparable. But when installed in the field, the ductwork and installation conditions will be different than how the fan was tested. Let's move this over and make a little more room. So let's pull up that fan curve from a couple weeks ago. Remember from the fan curve video that this is the system curve. If the system has more pressure, the system curve will shift to the left and the fan will have a lower CFM. Or if the system has lower pressure, the system curve will shift to the right and the fan will have more airflow. Let's draw in this airflow line as well. So changes in the system pressure will shift the system curve to the left or right, and the operating point will move along the fan curve to the new intersection with the new system curve. And you can see in this selection, if the resistance in the system changes too much, you could move close to or even inside the do not operate area. On the other hand, if your RPM increases or decreases, your operating point will move up or down the system curve. You can see that this will also increase or decrease the static pressure because you're basically pushing more or less air through the same physical system of ductwork. When an engineer designs an HVAC system, they can calculate the system resistance based on how much ductwork is in the system, whether the airflow has to change direction, what's in the system like diffusers, water coils, and so on. Let's make a little bit more room. Then they can calculate the system effect factor, which is based on the configuration of the fan in the system compared to the ideal situation in which it was tested. So the engineer can basically calculate the equivalent resistance in the system and use that to get the fan performance in their system that they designed. And hopefully the installation was designed to minimize the system effect. Let's move this kind of up into this area. So if the fan was installed differently from what was calculated, and if the system pressure goes up, then the airflow will go down and you won't get the airflow that you expected. Bad inlet and outlet conditions can increase system pressure, but I think I'll do a separate video covering inlet and outlet conditions and how to account for these conditions. So for now, that is what is system effect. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.